with another video. So in our previous video we talked about what is PyTorch and what is deep learning and how PyTorch is useful for deep learning and a lot of other stuff. So we also explained what is tensor, and we have shown you how to construct a tensor. So in this video we will cover how to index using PyTorch and some other basic stuffs of PyTorch. So this will be a relatively short video. So these basic stuffs are really important for our future topics, because if you don't understand the basic stuffs, it will be quite difficult for us to understand topics like deep learning, neural networks, and when we will be working with image and text data sets, so this will be quite difficult for us to understand. So I am giving emphasis on these topics. So let us dive into today's topic. So today we will study indexing. So what is indexing? Indexing is about accessing specific elements from a matrix or from a tensor. Previously we have created a tensor called A1 here. So let's run the whole cell. So today we'll work with the same AI tensor, A1 tensor. So we have reprinted it here, and so here you can see that we have a list like brackets and A1 with in the bracket we have 1:3. So what does it mean? So here we are trying to access the second and the third row. So how we are gonna define it? So we'll define it like this, like 1:3. So what does this mean? So this means that one is the, since we know in computer science we use array indexing, we start array indexing from 0. So here 0 means the first row and 1 means the second row. Okay, so second row, we are here printing the second row and the third row. So here 1 means the second row, and then if you write it like this 1 2 3, so here we are, so this line of code means that we are skipping the fourth row. So we are only accessing the second and the third row. So here you can see that this only prints the second and the third row. So if we want to only access the second row, we could have write it like this. Okay, our program is a bit slower due to some reason. Yeah, so as you can see why it's getting slower. Let me check. Okay, so we can also use a comma to write the column which we want to access. So here we are accessing in the second example we are accessing the second row and the third column. So here you can see this is the second row and this is the third column. So they're intersecting in which element they are intersecting. So they are intersecting at this element only, this one. So here we are printing that tensor 1, and similarly we are showing another example like from 1:3. So here 1:3 means the second row and the third row and the second column. So let's see where they're intersecting. The second row, this is the second row and this is the third row, and we are talking about the first column, sorry, the second column. So second column is this one, so they are intersecting at the 3 and 1. So here we are getting a tensor. This is like a printing as a row, so this is the tensor we are getting. So I'm just restarting the runtime to solve the issue. So also there are some other elements. So here you can see we have given here in the first example, I changed the code and only I wanted to print the second row. So you can see that the second row is printed 9312. So this is the way, this is how we can actually access different elements according to our wish. This might be useful in our future programs. So let's move on. So there are lots of element types or data types in tensor or in any programming language. There are data types, and when we are using tensors, so we often come across a lot of tensors. So in PyTorch there are tensors like float 32, or in any programming language we will come across these tensors like double, floating point, integers, 8-bit integers, 16-bit integers. So we can also check the integer of our array, that I mean the data type of our array. So if you write a1.dtype, then this will give us the data type. So if, since our a1 is a integer array or integer multidimensional array, so we are getting data type like this. We can also produce a like random. So if we like want to print the data type of b1, which we created previously, so let's see what we get. So b1 dot d type. See there, it's giving float 32, so 32-bit float. So we can also use another important function in PyTorch, which is called transpose. So we have probably in mathematics or in your college you have learned about transpose matrix. So transpose matrix, what it does actually, it actually changes the rows to column. So here you can see that when we are writing this code, the torch.transpose a1 01, so here 01 means that the row will be converted to column. So here you can see that the first row was 2 3 7 4, and here it is becoming a column. Similarly 9312 here becoming the second column. So this is how it gets transposed. We can experiment with another thing, like let's change the code a bit. Does it change our code? Yeah, you can see here that now the column becomes row. So here 2922 was the column, so now the column becomes the row. 3317 was the column here in the original matrix, so now it becomes the row. And similarly 7116 was the column and it becomes the row. So if we change it from 01 to 10, so it converts the, now this time it converts the column to row. This is quite interesting, right? So now we'll have to you can see that this line of code is showing an error. This is saying that no CUDA GPUs are available. So here we are checking that we are using any GPUs or not, and how to check that using code. So since we are calculating using A1, so we are giving A1.2 device CUDA. So in this case, for collab, we will have to change our runtime type to GPU. So now this code should work, and it will say, it will prove that now we are using a GPU. So it will take a bit of time since we have our runtime has got restarted, so we'll have to run all of them. So now you can see that this code should work fine, because now we have GPU running. So this will take a bit time. Also, we can also change our PyTorch tensor to numpy array in the form of numpy array. So we can use this function called points.numpy. So first we are saving a new tensor called torch.1 in using the variable points. So then we are creating another variable, and then we are calling .numpy with points. So this array type is now numpy arrays, numpy n-dimensional array. So in this way you can also change your array in the form of numpy array. Basically they are the same, but there are some slight differences between them. So at some stage, this changing an array from tensor to numpy could be helpful, because so often there are huge functionality in the Python ecosystem which is built up around the numpy array type. So if we can convert it, we can use it in other purposes. So they will the numpy array will have the same size, shape and numerical type. So it will not be a tensor by doing that. So it actually provides us a lot of flexibility in PyTorch. We can convert it into numpy array anytime to use other Python features, and then we can also convert it back to PyTorch again. So that's all from this video. Thank you all for your time, patience and understanding.